Good morning, afternoon, evening, whatever time zone you're in. Ladies and gents, this is day 4.5 in the workbook. Special cases, so perfect squares and difference of squares. We're going to focus primarily on the difference of squares, but in order to do that, you have to kind of know what a perfect square is as well. So, keeping all that in mind, it is April 17th, 2020. Could be any day, any time that you're watching this now, but this is when I'm recording it, so I'm saying that. This is for my grade 10 math group, but any individual looking forward to math class and needs a little additional clarification or anything like that, you're welcome to watch and try to learn. Mr. Benjamin here. Always smile. Learning goals for this lesson, we're going to discuss the three conditions. There are three very specific conditions required for a difference of squares. Okay, a difference of squares pretty much means what it sounds like. If you square a number and there's two differences, it'll make sense in a bit. We're also going to simplify complex polynomials by substitution, okay? In many cases, you're going to have polynomials that are a bit, how do you phrase this? They're a bit more complex, a bit more over the top, and using substitution, let x equal, let's not use x. A plus 2 makes it a lot easier, okay? So difference of squares. This is a type of factoring applied to an expression in the form of a squared minus b squared, and it has to be subtraction. In some cases you'll see addition, and that will not work. That is not a difference of square. In fact, that's one of those things, it's one of those things you have to keep in mind when looking at these questions. Let me put this in red. So, cannot be addition. Okay, very specific. It cannot be addition. And they have to be two perfect squares. And what is a perfect square? It's found by squaring an integer. So any number, positive or negative, is an integer. If you square that value, you should get a certain number. And these numbers are known. For example, 1 multiplied by 1 equals 1. 2 multiplied by 2 equals 4. 3 multiplied by 3 equals 9. 4 multiplied by 4, and so on. 7 multiplied by 7, you could do 9 multiplied by 9. These are all squared numbers, right? So 9 squared equals 81, right? There is a specific formula as follows. A squared minus b squared is equal to a plus b multiplied by a minus b. And that is literally the difference of squares. Okay? The conditions that must be met. This only works with binomials, which are two terms. So that a squared minus b squared. Okay? Must be a difference. Like I said earlier, it cannot be addition. So I'll write that again. Cannot be addition. I know when I was younger, I would see a squared plus b squared and think, oh, that's a difference of squares, easy answer, write it in. But you cannot do that for this. Okay, it just doesn't work that way. Otherwise, it would be called a difference of, or a addition of squares, and that's not what it is. It must be subtraction between two perfect squares. Okay, cannot be a number that's not squared properly. The constants and the coefficients must be perfect squares. So this example right here, 30. Well, that's not even right. It should be 6. Let me change that. So 36x squared is equal to 6x multiplied by 6x. If it was 36x, that does not, it's not a difference of squares, right? Because this 6 doesn't have the x with it. So that doesn't work. So both the constant and the coefficient. Let me label that out like I've done before. Let's do it right here. Sorry if the hand is in the way. 36x. Coefficients, constants. It's actually also a variable. Now, let me erase that because there is another condition that exists as well. If I had, my example here was 36x squared. If I had 36x squared subtract, say, 9, that would still be a difference of squares because that would give me 6x subtract 3, 6x plus 3. Sorry if you can't see this. Let me move it up here. Is that going to work? That's not going to work. I'll write it out again. So I'm going to get rid of this. So at the bottom here, I have written, and we'll write it in blue for some contrast, 36x squared subtract 9. This is a binomial, it is subtraction, and the constants and coefficients are both perfect squares. Because in this case, 9 is 3 squared, and 36x squared is 6x squared. So this value would be 6x plus 3 multiplied by 6x subtract 3. If we remember our formula, that is what our answer looks like. So that would work. Let's do some examples. Always factor if possible. I guess I probably should have factored this example, but that's okay. So in this case, x squared subtract 25. If I go back to my conditions, binomial, it is a difference, and they both are perfect squares, at least in my mind. 25 turns into 5, and 1 just turns into 1, right? Thinking about it, I'm pretty sure that works. Okay, so this is going to be x plus 5 and x subtract 5. Now if I FOIL this out, x squared and subtract 5x plus 5x subtract 25. And these two will cancel out, so I'll be left with x squared subtract 25. It's always great when we can go back and check. And our check is correct, so we're good. Let's do the next example. This is just written the other way, but I mean, we can change it if we wanted to, right? I'm going to leave it like this because it's a difference. So 1, the root of 1 is 1. So bracket 1 subtract 49 would be 7. And I have my x squared, so that's x. And 1 plus 7x. We can go back and FOIL that, and we will get the same value as well. Let's do that really quick. So 1 multiplied by 1, 1. Plus 7x, subtract 7x. And that's subtract 49x squared. Those will cancel out, so we'll be left with 1 subtract 49x squared. Check, done. Alright, let's look at this last example. Where'd my purple go? I lost my purple. Give me a second here. Is this the same color? No, it's different. But you know what? I kind of like that one better. So I've got 4x squared minus 16. Now, in this case, I can factor out. I can take out a whole 4. X squared minus 4, right? So this 4 is going to remain with us. I will be left with 4 multiplied by x. Square root of 4 is 2. X plus 2, x minus 2. There really is no difference. I think I wrote the negative here and the positive here in that example. There's no difference in where you write the plus and minus because it's the exact same function. It'll work out the same way. Right? Now, if I didn't factor the 4, what would this look like? I would have 2x subtract 4 multiplied by 2x plus 4. Right? Exact same thing. I can just factor out a 2 here, and it will still work out. Okay, some cases, this is where the substitution comes into play. I've got x plus 4 here and negative 9. So what is this going to look like? If we let x plus 4 equal a, or you can write the other way around, let it a equal x plus 4, and I rewrite this, it's going to give me a squared subtract 9, right? Let me write this in a different color because it's a new function. Same function, but it looks different now. A squared subtract 9. So it is still a difference of square, right? Unless I've gotten this completely wrong. A subtract 3, and oops, not x, excuse me. A plus 3. Now, that is our difference of square for that function. But we said let a equal x plus 4. So now I kind of have to resubstitute in those values. I was thinking to myself, I may need some more room here, so I may have to rewrite this question out, but that's okay. So sub back in that portion. So what are we left with? Bracket x plus 4 subtract 3 multiplied by, let's do some square brackets around here, keep it in check. X minus 4 subtract 3. Okay. Now, I'm going to bring this back up to the top. I'll rewrite it just for some clarity. So what we can do is we can evaluate what's in the bracket and kind of bring it out. Because there's nothing in front of this bracket here, it'll just be what it looks like. X plus 4 subtract 3. X subtract 4 subtract 3. So we'll end up with x plus 1 multiplied by x subtract 7. And that will be the answer to that guy there. It looks kind of weird, I know. But it'll work out. Let's give myself some more space for this guy. So we've got 25x squared subtract y squared. So we do have a difference. We do have values that can be squared or can be rooted to get an answer. So what are we looking at here? 25, so this will all equal 5x subtract y and 5x plus y. A lot simpler, that one. This one can be a bit difficult, but the grouping really helps, and then just working it out should be the solution. So shorter video today. I think that makes a lot of people happy. Thank you with a happy face. Hope everyone's doing well. Everyone stay healthy. Everyone pray for a cure. Have a great day.